But B itself can exist in two forms. One is a D form and the other one is L form. So far you have three isomers. Now let's imagine that you are placing the chlorine on, say, on third carbon. So here you remove the hydrogen and put this here. Now, sir, is it a chiral carbon?
No, sir.
No, sir.
It's not. Okay. Therefore, C, A, B, C are position isomers. C cannot exist in object and image form because that is not chiral. Now let us remove that. Let's put a hydrogen as usual. Now let us do one thing. Let us put a Cl in this position, in position 4. Further, you have to remove one hydrogen. I removed hydrogens. Sir, whether I put the Cl on 4th carbon or 5th carbon, both are same. Agreed or not?
Yes, sir.
Therefore, when I put here Cl, will the 4th carbon be chiral?
No, sir.
4th carbon is not chiral. This is case 1, 2, 3 is over. Case 3 is over. I have forgotten to write that. Case 3 is not chiral. Case 4. Case 4, 4th carbon is not chiral. Definitely yes.
But
And
the third carbon will become chiral.
first carbon is not chiral. First carbon is not chiral. Second carbon is not chiral. What about third carbon, sir?
Yes, sir. It is chiral.
Third carbon is chiral. Therefore, when I am placing Cl on carbon number 4, it can be D dash. Because it has a chiral carbon, it can have object and image forms. Can you see it, sir? Hello?
Yes, sir.
Notice, on 5th carbon, I did not have to try because 5th carbon, 4th carbon are same. But that is CH3, this is CH3. Right?
Yes,
right?
sir.
So total how many compounds I got? I will count. 1, 2, 3, 4, 5, 6. Total 6 compounds. But if I am distilling, B dash, D dash will have same boiling point. So they can't be separated by distillation. So if I try to distill, I get only 4 units.
4 fractions.
1 unit is A, 1 unit is B dash, 1 unit is C, 1 unit is D dash. That is, I get 4 fractions. I get 4 fractions, but 6 compounds. So 2-methyl butane on monochlorination can give me 4 fractions on distillation, but actually it can give me 6 different compounds. Out of the 6, there are 2 enantiomeric pairs. The enantiomeric pairs are like 2-chloro-3-methyl butane and also 1-chloro-2-methyl butane. In 1-chloro-2-methyl butane, second carbon will become chiral. In 2-chloro-3-methyl butane, second carbon itself is chiral. Are we very clear about it, sir? Hello? Hello?
Yes, sir.
This is the IIT advanced question that appeared earlier. Now, I try to go to some questions. At least our objective is to do some 20 questions today. Are you seeing my screen, sir? Are you seeing my screen?
Yes, sir.
This compound is prepared by Dr. Govardhan Mehta of University of Hyderabad. He called it as Golcondain. He called it as Golcondain. Okay? Okay. Okay? Now, if I take Golcondain structure 2, how many monochloro derivatives it can give? Consider only structural isomers, don't bother about stereo. You don't have time. Take structure 2, how many monochloro derivatives it can give? Sir, we have less time, sir. Golcondain, exactly 3. Congratulations. You are fit to go for IIT entrance, I tell you. Because you see, if I look at position 1, position 7, they are identical. Can you see that? Position 8, position 10 are identical. Position 3, 5 are identical. Yes?
Yes, sir.
So they can have only 3 monochloro derivatives with this compound. That's a good question. You have answered very correctly. Now we are going to look at this is a lot of time, man. Did we discuss yesterday's paper, by the way? Hello. Did we discuss yesterday's paper, day for yesterday's exam paper? Any doubts are there in that paper?
No doubt, sir.
You have doubts or no doubts? It takes a while to get uploaded. Narayana Senior Chemistry Advanced Volume 3. No. Okay. By the time it uploads, I can take up one more question. Or I'll cross it. I'll just cross it. It's taking time. Everything is taking time and we have no patience. Okay, not opening. Let me not waste time on that. The system is somehow very slow.
Sir, I have
Okay.
a doubt, sir.
So, sir, this topic, you can keep me asking your doubts in the previous papers or whatever. Come on.
Yes, sir. The halogen which is most reactive in the halogenation
It's
of
fluorine.
substance under sunlight.
Fluorine is much more reactive in the darkness. If you are putting light, in presence of light, chlorine is more reactive. Chlorine,
Okay, sir.
because ClCl bond is weak, that can be broken readily. And chlorine is more reactive in halogens as far as presence of light is concerned. Okay. So now we are making a last final review of this textbook in 10 minutes, then questions in 20 minutes. I think we have 30 minutes. Sir, have you recognized this compound? 1,1,1 trichloro, 2,2,4 chloro, 2,2-bis 4-chlorophenyl ethane, DDT, and it is not in use nowadays. Because the United States has banned it in 1973. India is still using sometimes, but it is definitely a poisonous, environmental unfriendly compound. Freons are compounds which have both fluorine and chlorine. They are named as freon A, B, C. If A is not specified, it means they are not telling carbon. Carbons are to be specified as number of carbons minus 1. If you say freon 012, 0 indicates that it has only 1 carbon. And the 1 is indicating that it has 2 chlorines. And 2 is indicating that it has 2 fluorines. So this is the way generally freons are named. You can check in the internet if you are interested to know the nomenclature of freons, but that is out of syllabus because freons themselves are to be banned because freons are fluorochlorocarbons which are supposed to be non-poisonous, non-toxic, but they are supposed to cause the ozone layer depletion, so they are not in use. Freons are usually prepared by the Swart reaction. You take CCl4 and bring about Swart reaction. That question appeared earlier. Swart reaction. You take CCl4, carry on Swart reaction. Okay. Next thing is the CCl4 carbon tetrachloride once widely used. Nowadays, chlorocompounds are not in use much because of the pollution problem they cause. CCl4 was earlier used in every household as a cleaning agent. But because of the possibility of cancer generation, carcinogenicity, it is not in use. The carbon tetrachloride is not soluble in water. It is used as a fire extinguisher. It can extinguish the fire. So carbon tetrachloride vapors, if we inhale, we are likely to get the liver cancer. Therefore, the CCl4 is not to be worried much, but every laboratory has CCl4. CHI3 iodoform is used once as an antiseptic, and because of the bad smell it gives, it is not in use. Chloroform was once widely used as an anesthetic till 20 years back. Now chloroform is not used as an anesthetic because of possibility of COCl2 formation, phosgene formation due to aerial oxidation. Notice phosgene can be destroyed by adding ethyl alcohol. You take chloroform, add a little ethyl alcohol, phosgene can get destroyed. That's not an issue. The issue with chloroform is it is supposed to cause cancer in the long-term use. Carcinogenicity is the big problem. Okay. Moreover, if some people who are allergic comes in contact with chloroform, they get skin rashes and irritation. Dichloromethane or methylene chloride is an important solvent used in the paint industry. And it is such a dangerous compound. If a drop falls on your body, it can penetrate through the skin and it can cause a serious damage to muscle. I know one Sunita who suffered from this problem. So while handling dichloromethane, one should be very careful. So these are some polyhalogen compounds used in our day-to-day life. Now this is the last 10.7. Which of the following pairs would you expect to react more readily by an SN2 mechanism? Primary alkyl halides undergo SN2. In 10.7, one will undergo SN2. Two may undergo SN2 if the solvent is aprotic. But as a rule, one undergoes, in the first option undergoes SN2. Now when you have second thing, you have 2-bromobutane and 2-methyl 2-bromopropane. One is secondary butyl bromide, the other one is tertiary butyl bromide. Secondary butyl bromide prefers SN2. All this you can answer, the answers are also given in the textbook. And you should try all the questions, identify A, B, C, D, R, R dash in the following. First thing is you get Grignard reagent. When Grignard reagent is kept in water, you get cyclohexane. When alkyl bromide reacts with magnesium and either you get alkyl magnesium bromide. When it reacts with D2O, deuterium will come in. So no RD you will get. The RD is given as 2-deuteropropane. Therefore, R must be propyl group. Therefore, it must be 2-bromopropane. Can you see? The place where Br was there you get deuterium. Therefore, the original compound is supposed to be 2-bromopropane. So like that, you should try all these questions. Please try them. And if you have doubts, you should ask me. The lesson is to be read thoroughly. These are the characteristic reactions of halobenzene, chlorobenzene. Notice that the benzene is not interested to exchange Cl- with Y-. It is not interested in nucleophilic substitution because CCl bond has strength double bond nature due to resonance and due to sp2 hybridization state. If you forcefully remove Cl-, phenyl carbocation forms, which is unstable. And also the electron clouds repel on either sides for the entry of Y-. So generally chlorobenzene is not interested in nucleophilic substitution unless you put some withdrawing groups on benzene like NO2. The chlorobenzene may undergo replacement of H plus with E plus. The Cl minus replacement with Y minus is nucleophilic substitution. Cl minus, Y minus are nucleophiles. Whereas H plus replacement with E plus is called electrophilic substitution. The electrophilic substitution can happen on chlorobenzene, but because Cl is a electron withdrawing inductive effect group, the chlorobenzene is not really more reactive than benzene. But anyway, well, chlorobenzene can undergo electrophilic substitution. When chlorobenzene undergoes electrophilic substitution, the electrophile prefers to come to second position, ortho position, or fourth position, para position. Hence, chloro is called ortho-para dialectic group. The electrophile can be like your other chloride, Cl plus in phenylcraft chlorination. It can be NO2 plus, like nitration. It can be CH3 plus, like alkylation, so on. See, these are the reactions which they have shown. You should study the canonical forms. If you have chlorobenzene and go for Friedel-Crafts alkylation, the methyl group will come to second position or preferably fourth position. Second position is not preferred because of steric repulsion. If you go for Friedel-Crafts acylation, the acyl group can come to second position or fourth position. Fourth position is preferred because of same reason. So these are the reactions of chlorobenzene with nitric acid. The nitration also 4-nitrobenzene is major product. In sulfonation also 4-chlorobenzene sulfonic acid is major product. Carefully observe, sir, 4-chlorobenzene sulfonic acid. Have you observed, sir? Have you observed?
Yes,
It is
sir.
a very, very, very important compound. Instead of chloro, if I put CH3 there, it is called toluene sulfonic acid. Instead of chloro, if I put CH3, it is called toluene sulfonic acid. Toluene sulfonic acid is a very, very important compound later on we see. It is called Hinsberg reagent. Hinsberg reagent is made from that. We will be seeing why it is important later on. But all these are called electrophilic substitution reactions of chlorobenzene. Notice, if you compare benzene and chlorobenzene, benzene is better. If you compare nucleophilic substitution, electrophilic substitution is better. If you want to carry out the electrophilic substitution, the incoming group always comes to ortho and para positions, because chloro is the ortho para directly. Now here we are looking at the chlorobenzene where the Cl is replaced by OH minus. If you want to replace Cl with OH minus, reaction is dead slow. If you are putting NO2 groups which are electron withdrawing, the electron withdrawing groups can weaken CCl bond. Why do they weaken? That has been represented and explained in this. I want you to read in particular. Kindly observe that chlorobenzene requires a drastic temperature pressure condition to become phenol, whereas 4-nitrochlorobenzene requires just 443 K. That is 623, it is 443. Whereas 2,4-dinitrochlorobenzene requires just 368 K. And very interestingly, if I put 3 nitro groups, it just requires water and warming. Nothing, even NaOH is not needed. It means the Cl minus replacement with OH minus will become very, very easy if I am putting NO2 groups. Because NO2 groups are electron withdrawing. They weaken the CCl bond. It has been explained with the diagrams here. I want you to carefully go through it at your leisure. This is how chlorobenzene reacts with the SN. Why the chlorobenzene is less reactive for replacement of Cl minus with Y minus? 4 reasons they give. For board exam, generally the 4 reasons you have to write. Here you have the nucleophilic substitution of benzene is not really preferred because 5 canonical structures it has. They have shown only 4 here, 5th one you should write. You have seen what is Grignard reagent and its significance. You understood that the reaction of alkyl halide with metals like magnesium will give Grignard, like sodium will give Wood's reaction.
Yes, sir.
It is a comparative account of SN1, SN2 reactions. Always there is a competition between elimination and SN reaction. In elimination also, I have to specify one point very clearly once again. I need to explain it because this is so important. The elimination reaction of this particular compound, if I take, I have Br here. This Br which is there in carbon, I call it as carbon auntie, carbon boy, carbon chutney, carbon donkey. Sir, now I have a problem. Let me also put a ethyl group on carbon. Now, sir, the Br minus definitely would go in elimination when I heat with alcoholic KOH. or NaNH2. The Br minus goes with the hydrogen of next beta carbon. It is a beta carbon. It is a beta carbon. It is a beta carbon. How many beta carbons it has? 3. Now I want to examine the number of hydrogens. This beta carbon C has 2 hydrogens. This beta carbon B has 1 hydrogen. This beta carbon D has 3 hydrogens. Can you see it, sir?
Yes, sir.
Now, when the alcoholic KOH or NaNH2 is added and heated, the Br minus goes with that carbon's hydrogen, which has less hydrogens. It means this hydrogen is preferably removed, and you will be getting this compound preferably. Can you see it, sir? This product, if you are getting as a major product because of the elimination of this hydrogen, I would say that in the elimination reaction, the hydrogen is eliminated from that beta carbon which has the least number of hydrogens. It is called Sedgwick rule. And the product is called Sedgwick product. This is the major product. If the hydrogen is eliminated from that beta carbon which has more hydrogens, you get a product like this. This product is really a rarity. It is called Hoffman product. In order to get Hoffman product, if you want this to happen, if you want to get this product, nobody else, you are going to remove this hydrogen. This hydrogen, this carbon's hydrogen can be removed, not by Br. You take a very bulky base like C4H9O, sodium tertiary butoxide. It is such a bulky base. It is so crazy about H+. It will just come to any one end and take away H+. When the H+ is taken away by the tertiary butoxide, this electron, that the negative charge, carbon is not able to bear, it will pull the electron pair here, that will become a double bond. Then immediately Br minus is ejected out. This is a strange reaction where you are getting Hoffman product by a bulky base or at high temperature. Mind you, this is a comparison. Always elimination is competing with substitution. So we have covered the entire NCERT textbook thoroughly. I wanted to read the NCERT textbook line by 15 times before you go to the next topic. Please prepare thoroughly and ask me every silly doubt. Sir, page number 3, I did not understand line number 1. Page number 7, I did not get the table. Page number 10, I did not get the diagram. Page number 21, I could not get the answer to the question given. Like any question and every question you are allowed to ask, but you have to read the NCERT thoroughly. Okay, sir?
Okay,
Hello?
sir, I have a doubt.
Yes, sir.
Now, your doubts.
Sir,
Ask your
suppose in the question, it is not specified that which kind of isomers we need to find. So should we consider stereoisomers or not?
If it is not specified, you have to consider stereo. You have to consider. There is no way. Generally, they ask structural isomers. They clearly ask.
Sir, they ask structural generally.
Okay. Any more doubts? In fact, today, Ajit sir has come to my home and gave me a voluminous book, MTG, Mathematics Teaching Group Chemistry. He wanted me to scan and tell my opinion. Very good. Every book and every book is fine, but textbook is super fine. So first we have to master it. For organic chemistry, mastering textbook is a must. Okay?
Sir, can you say about Hanslicker reaction?
Sure, sir. I will give the mechanism also.
Okay, sir.
Sir, this is a compound you have CH3COOAg. If you want to prepare this compound, you take carboxylic acid, react with the silver oxide. Silver oxide is actually, if you are adding water, it will become silver hydroxide. Moist silver oxide means silver hydroxide only. So I will put aqueous. The aqueous AgOH is a base and the carboxylic acid is an acid. Acid plus base will give you salt plus water.
Yes, sir.
So whenever you take a carboxylic acid, you add moist silver oxide, you will be getting silver salt of carboxylic acid. That's number one. Now in Hunts-Dicker reaction, you take the silver salt of a carboxylic acid and simply add bromine. Now this bromine is having a crazy attitude, like the bond can break homolytically, giving a Br free radical, Br atom. That Br atom will take the silver atom and get precipitated as AgBr. Notice, and silver atom is getting, you are getting COO with one electron and shortage of a bond.
Yes, sir.
Urgently, this part will break down to give carbon dioxide, and at the end, CH3 will have an unpaired electron. Now, the CH3 having one unpaired electron is called free radical. This free radical and Br free radical, because Br will break into two Br atoms. The Br atom and the CH3 free radical. They both very rapidly combine to give CH3Br. So in Hunts-Dicker reaction, always there is loss of CO2. Always the alkyl halide produced has one carbon less than the parent. Reaction proceeds very rapidly because AgBr precipitate provides a driving force. Because one of the product is removed as precipitate, reaction easily goes in the forward direction. Hunts-Dicker reaction is used to prepare alkyl bromides preferably, which have one carbon less than the starting carboxylic acid. What else?
Understood, sir.
Our next topic is alcohols. Alcohols topic is a very big topic because alcohols, ethers, aldehydes, ketones, carboxylic acids. All these five, there is a major topic that takes roughly 4 weeks time. All these compounds contain oxygen and they are so significant that most of the organic chemicals which we use are belonging to this category of oxygen containing compounds. And of all these oxygen containing compounds, alcohols are very, very significantly known. You see, in Hyderabad city itself, about 100 crores of alcohol is consumed on monthly basis. People are drinking like fishes. And if this Saturday, Sunday comes, means the bars will be really very crowded, it seems. The alcohol is so important not only for getting a kick, alcohol is also important as a constituent of medicine. So many cough syrups are made with alcohol. Alcohol is also used as a surgical spirit when there is a surgery. If you know how to produce alcohol at a cheap price, alcohol can be also used as a fuel. Okay? So, alcohols are important compounds about which we are going to start our study tomorrow. Alcohols and ethers, they have same formula. CnH2n plus 2O. Both alcohols and ethers have same general formula, but alcohols are more reactive than ethers. If you put sodium metal in alcohol, immediately you can get hydrogen gas and fire. If you put sodium metal in ether, nothing happens. Why the difference in the behavior will be examined in the next classes to come. But today I want you to completely do the alkyl aryl halides thoroughly once again. Also complete the material which I have sent to you. And if you are thorough, we can happily travel into alcohols. Definitely it will take 4 weeks because slowly I want to do 1 week alcohols I will do. 1 week I will do phenols. 1 week I will do ethers. 1 week I will do aldehydes and ketones. 1 week I will do carboxylic acids. So 5 weeks, the lesson continues. till the half part of July. Slowly we have to go, we are not in a hurry. Okay, sir?
Okay, sir.
So here we conclude our class, and your homework is to do all the in-text questions and the questions given at the end of the lesson in alkyl halides, and ask me what are your difficulties. Last day to ask all your doubts in this chapter is 10th of this month. After 10th of this month, nothing should be left in this topic. Okay,
sir.
sir? So that note, I am closing the class. I wish you good luck.